How your immune system hunts viruses. The immune system is the body's natural defense network. Its job is to detect, attack, and eliminate harmful invaders such as viruses. When a virus enters the body, the immune system launches a coordinated response involving different cells, proteins, and organs to stop the infection and protect the body from disease. 1. Virus entry into the body. Viruses usually enter the body through the nose, mouth, eyes, or breaks in the skin. Unlike living cells, viruses cannot reproduce on their own. They must invade human cells and use the cell's machinery to make thousands of copies of themselves. Key point: a virus depends on host cells for survival and reproduction. 2. The first line of defense: innate immunity. The innate immune system is the body's immediate response to infection. It acts within minutes or hours after a virus enters the body. Major components include skin and mucous membranes, macrophages, neutrophils, natural killer NK cells. These defenses help slow down the infection before the specialized immune response begins. Key point: innate immunity is fast but not highly specific. 3. Alarm signals: interferons. When cells become infected by a virus, they release proteins called interferons. Interferons warn neighboring cells about the viral threat, reduce viral replication, activate other immune cells. Think of interferons as the body's emergency warning system. 4. Macrophages, the first hunters. Macrophages are large white blood cells that patrol the body searching for pathogens. Their functions include engulfing and digesting viruses, removing dead or damaged cells, presenting pieces of the virus to other immune cells. Because they both destroy pathogens and gather information, macrophages act like the immune system's soldiers and detectives. 5. Dendritic cells, the intelligence officers. Dendritic cells capture pieces of the virus and travel to nearby lymph nodes. There they present viral antigens to T cells, essentially saying, "This is the enemy. Prepare for attack." This process activates the adaptive immune system. 6. T cells, the specialized attack force. Helper T cells, CD4+. Helper T cells coordinate the immune response. They activate B cells, activate killer T cells, release signaling molecules called cytokines. Without helper T cells, the immune response would be much less effective. Cytotoxic T cells, CD8+. Also known as killer T cells, these cells destroy virus-infected cells. They identify infected cells and trigger them to self-destruct, preventing the virus from spreading further. Key point: sometimes the best way to eliminate a virus is to destroy the infected cell that contains it. 7. B cells and antibody production. B cells are responsible for producing antibodies. What are antibodies? Antibodies are specialized proteins designed to recognize and bind to a specific virus. Functions of antibodies: neutralize viruses, prevent viruses from entering cells, mark viruses for destruction, help other immune cells locate targets. Each antibody is highly specific to a particular pathogen. 8. Inflammation and fever. During infection, the immune system causes inflammation. Common signs include fever, swelling, redness, pain. Fever is beneficial because it can slow viral growth and improve immune cell activity. Key point: many symptoms of illness are actually signs that the immune system is actively fighting infection. 9. Eliminating the virus. As antibodies and T cells increase in number, the immune system gains control of the infection. The body then destroys infected cells, neutralizes free viruses, removes cellular debris, repairs damaged tissues. This is the recovery phase during which symptoms gradually disappear. 10. Immune memory, learning from the battle. After the infection is cleared, some B cells and T cells remain in the body as memory cells. These cells remember the virus and can respond much faster if the same virus enters the body again. Benefits of immune memory: faster detection of the virus, rapid antibody production, stronger immune response, reduced risk of severe illness. 11. How vaccines help bring the immune system without causing the actual disease. They expose the body to a harmless version or component of a virus, allowing it to create memory B cells, memory T cells, protective antibodies. As a result, if the real virus enters the body later, the immune system can respond quickly and effectively. Most important points: viruses must infect living cells to reproduce. Innate immunity provides the first line of defense. Interferons act as warning signals during infection. Macrophages engulf and destroy viruses. Dendritic cells activate the adaptive immune response. Helper T cells coordinate immune activities. Killer T cells destroy infected cells. B cells produce antibodies. Antibodies neutralize and mark viruses for destruction. Memory cells provide long-term protection against future infections. Conclusion: the immune system is a highly organized defense force that hunts viruses through detection, communication, attack, and memory. By combining the actions of innate immunity, T cells, B cells, antibodies, and memory cells, the body can eliminate viral infections and build protection against future attacks.